Question 21 also seems to be causing some issues. Let me just see if I can get it so I can see all of this page at the same time. You've got a situation where you are told that the number of customers coming into a 24-hour convenience store has every 10 minutes is Poisson distributed with the mean, I don't know why there's a double A here, the mean being 5.4 customers. So that's the number I got. Maybe you got a different number. I'm going to focus here on lambda and what it means. So lambda is the number of customers coming in a 10-minute chunk. And therefore, you could make a random variable where you're counting the number of customers that could possibly come in a 10-minute interval. And that should be somewhere close to around 5.4. So that's Poisson, counting the number of customers. That's a discrete count. However, we could also, instead of talking about customers per 10 minutes, we could flip this around and we could get the amount of 10 minutes per customer. So that's the reciprocal. So here, if I have 5.4 customers every 10 minutes, then instead of having 5.4 over 1 or 5.4 over 10 to get customers per minute, I could instead say 10 divided by 5.4, which would get me the number of minutes per customer. Okay, so here I could really invert that into how I could think about an exponential, and that is not the number of customers in the 10 minutes, but instead how many minutes until the next customer. So here we're targeting number of people, and here we're targeting amount of time. So the first thing that you're going to need to do is, like I sort of alluded to, you're going to have to reparameterize this success rate. Instead of in terms of 10-minute chunks, you're going to have to convert it into just 1-minute chunks. So you can then either talk about lambda, which is the number of customers per some time, to a beta, which is the reciprocal of lambda, which would be some time per amount of customers. So here, what you'll need to do, of course, is to reparameterize and to take the reciprocal. And then you can start talking about here how many minutes. What is the expected value of an exponential distribution? And also, when you are trying to calculate the probabilities that you will be calculating throughout the question, remember here that this question B is talking about if at most 2 minutes will pass by. So it is actually in terms of minutes and not in 10-minute chunks. So here my suggestion is to reparameterize very carefully in terms of minutes and not in terms of 10 minutes. So what I mean by that is you should not be using 1 over 5.4. You should be using 10 over 5.4 if, of course, you had the same 5.4 that I had. Then, of course, you are trying to find the cumulative probability. If you're using R to find a cumulative probability, that is that the sign is the less than or equal to sign, then use the command with a P. And then to reference an exponential, it would be P exp. And then you can put in the number here, which happens to be 2. And here you can either put in lambda or you can put over 1 over beta. But be careful, of, again, of course, that this is lambda or beta in terms of minutes, not in terms of 10 minutes. So here, if you were going to use lambda, it would be 5.4 over 10. And if you were going to use beta, it would be 10 over 5.4. There's also the handwritten formula that you could use if you like. When it comes to finding the probability of being in between two values, again, you can use the two cumulative probabilities. So here, the cumulative probability of the upper tail minus the cumulative probability of the lower tail. If you take the difference of those, you will in fact get the area in between. Sorry, I see here that I've written this correctly, P exp, but here I only wrote P. It should be P exp, and this should also be P exp. Sorry for that. Finally, the last part of the question is talking about some conditional formula. So here it says at least 1 minute has passed. So you already know that this happened. That's past tense. So here, in my case, x is already greater than or equal to 1. That has already happened. What is the probability that in total x is at least 3.5? So here my b would be 3.5 and my a would be 1. Using the conditional probability formula that we talked about earlier in the course, I can actually split this up into an intersection divided by the condition. And here, the numerator, x is greater than or equal to 3.5, and x is greater than or equal to 1, can really simplify where here the only things that are in common with a number that's greater than 3.5 as well as a number being greater than 1 is that number actually being greater than 3.5. So then when I'm trying to actually find the answer for this or compute it in the calculator or in the computer, notice that the sign here is not the less than sign as it was above in B and in part C, but instead it is the greater than sign. So instead of using the less than sign or the greater than sign, here are, when you use P, exp, is actually giving me the less than sign. But if I do 1 minus the less than, I get the greater than. So here, if I'm trying to formulate the numerator, I can say 1 minus P exp, which will get me the greater than sign, and then I put b and 1 over beta. And then here I can divide that by, again, using the complement of the less than sign to get me the greater than sign, 1 minus p exp of this value, which I saw was 1 in my particular question. I hope that helps.